Hi guys, welcome to my channel. Today we'll be discussing about summary of the properties of all the quadrilaterals, deep dive into the transversal and the parallel lines. So here I have mentioned shapes and have written all the different types of quadrilaterals. These are the four criteria on which you will find they have the different characteristics or properties. In a parallelogram, what about the sides? Opposite sides equal always. In a rectangle, opposite sides equal. The rhombus, all sides equal. Square, all sides equal. Kite, adjacent sides equal. For trapezium, nothing can be said. It can have equal, it cannot have equal, anything can happen with. There is nothing fixed. But in parallelogram, this is fixed. In rectangle, opposite sides will be always. This will be always. Square, all the sides will be equal always. In rhombus, all the sides will equal always. Trapezium, we don't know. It can, it cannot. So just put a blank. Let's see the angles. Opposite angles are equal. In rectangle, all 90 degrees. Always. In rhombus, opposite angles are equal. Rhombus, this is equal to this is equal to this. Always. Here it is 90, 90, 90, 90. Opposite sides equal. Here all sides equal. Here this is equal to this and this equal to this. Square, all angles are 90 degrees. Kite, what happens in kite? Only one opposite angle is equal. Trapezium, not known. Opposite angles can be equal, cannot be equal, cannot be. Nothing is known. The diagonals bisect each other. If you join the diagonals of a parallelogram, and this is the point of intersection, and these are the four sides A, B, C, D, that means BO is equal to OB and AO is equal to OC. So it just bisects. There are two diagonals in parallelogram. So when you join the opposite vertices of a parallelogram, the diagonals will intersect, cross each other. They will cross at some point. Let us say that point is O. So ABCD is a parallelogram. You have joined that diagonal, joined the vertices to make that diagonal. The common point is O. Now when you measure, you will find AO is equal to OC. DO is equal to OB. So they bisect. 2 centimeter, this is 2, this is 5 and this is 5. This is total 10 centimeters but 5. This is 4 centimeter, 2. Bisect. So here only bisects in parallelogram. What about rectangle? It bisects. When you join the diagonals of a rectangle, they also bisect each other, but bisect equal. When you join the vertices in case of rectangle, the diagonals are of equal size. A, B and CD, in that AC is equal to BD, always in rectangle. So diagonals will bisect also and diagonals are equal also. What about rhombus? In rhombus, bisect. In rhombus, when you join the vertices, the diagonals bisect each other. Same as parallelogram. Rhombus is also a parallelogram. So obviously it has the characteristic of that. So that means there also it bisects. But the diagonals bisect at 90 degrees. So bisect and perpendicular also. This is 90 degrees, which is not in the case of this. Squares, this is the most interesting because square is a quadrilateral, trapezium, which is a kite, which is a rhombus, which is a rectangle, which is a parallelogram. So in case of square, the diagonals bisects each other. They are equal also. They are perpendicular also. In kite, only one diagonal bisects and it is perpendicular also. Suppose say the kite looks like this. Agreed? something like this kite. You join this, you join this, you join this. Let's say this is 5 centimeter, 5 centimeter, 12 centimeter, 12 centimeter. Adjacent sides are equal, 5, 5, 12, 12. You will see this is equal to this. Only one diagonal bisects and perpendicular also. But you see, if we take this, AO is not equal to OC. When you divide, only one diagonal is half-half. But other diagonal no half-half. That means one diagonal bisects and they are perpendicular to each other. So only one opposite angle is equal. In this, this will be equal. Angle B and angle D. Why? You see triangle ADC and triangle ABC. There are two triangles. AD is equal to AB, BC is equal to BC, and AC is common. So both the triangles are the same size. All the sides equal. That means this angle is equal to this angle. Only one opposite angles are equal. This one and this one. So these angles are equal. In a parallelogram, opposite sides are parallel. Rectangle, opposite sides are parallel. Rhombus, opposite sides are parallel. Square, opposite sides are parallel. One pair is parallel. There are four sides in a trapezium, at least one pair parallel. In kite, opposite sides will be parallel or not parallel, doesn't matter. Transversal and parallel lines. A transversal is any straight line which intersects with two or more parallel lines. There can be infinite parallel lines, not limited to two or more. Draw any line like this, straight line. So this is a transversal. There are many angles created over here. This is angle 1, angle 2, angle 3, angle 4. This is angle 5, angle 6, angle 7, angle 8. Angle 4 is equal to angle 5. Angle 3 is equal to angle 6. These angles are equal and they are alternate interior angles. 3 and 6, they are alternate interior. Interior because they are inside the parallel lines. Alternate because they are on the opposite side. Same with 4 and 5. 1 and 6, angle 2 is equal to angle 5. Angle 3 is equal to angle 7. Angle 4 is equal to angle 8. These are corresponding angles. This one, this one. This one, this one. This one, this one. And this one, this one. 1 is equal to angle 3. Angle 2 is equal to angle 4. Angle 5 is equal to angle 8. And angle 6 is equal to angle 7. Vertical angles. These are vertically opposite angles. 1 and 3 they are equal. 2 and 4 they are equal. 5 and 8 they are equal. 6 and 7 they are equal. So corresponding angles are equal. Alternate interior angles are equal. Vertical angles are equal. Let us check alternate exterior angles. That means these are alternate interior and these are alternate exterior. So angle 1 is equal to angle 2 is equal to angle 8. 2 is equal to 8. 1 is equal to 7. 8 is equal to 2. 7 is equal to 1. Yeah. So these are alternate. Supplementary angles. Supplementary angles means when you add two angles, it is 180 degrees. 7, 8, 5, 6, 3, 4, 2, 1, 2, 3, 1, 4, 6, 8, 7, 5. When you take these two always, these two 180, these two 180, these two 180, these two 180. Straight lines. And the last one, an important one, consecutive angles. The consecutive angles are always add up to 180 degrees. Angle 3 plus angle 5, always 180 degrees. Angle 4 plus angle 6 is equal to 180 degrees. These are consecutive angles. You will get 180, 90 in many cases, but which one to add to get 180? When you add this, we will say consecutive angles. When you add this, we will say linear pairs, or we will say they are supplementary angles. Total 180, but they are coming from different places. When you take any quadrilateral, for example, square, rectangle, rhombus, kite, or trapezium, the sum of the interior angles, 4 angles, will be always 360 degrees. Let us take one example and try to understand. This is some quadrilateral. We don't know what is this. It looks like a trapezium, but let us say whatever it is. ABC are 4 vertices of a quadrilateral. And if you're asked to find the sum of the angles of A angle B, C, D, the total, the best technique is to join any one diagonal, to join any 2 vertices to form a diagonal. And then you will notice you will get 2 triangles. For example, here you have ABC and triangle DAC. Let us name all these angles. Angle 1, this is angle 2, this is angle 3 in triangle ABC, and in triangle DAC, angle 4, angle 5, and angle 6. Sum of the angles in a triangle is 180 degrees. Sum of the angles in a triangle is 180 degrees. So when we add angle 1 plus 2 plus 3, we should get 180 degrees. SC, when you add all the angles, that is angle 4, 5, 6, you get 180 degrees. This is 1, this is 2. You add 1 and 2, what you get? You get angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6 is equal to 180 plus 180, that is 360 degrees. So we will write here angle A plus angle B plus angle C plus angle D and check what is the total angle, sum of the total angles. So angle 1 is angle A is angle 1 plus angle 5, B is angle 2, C is angle 3 plus angle 6, and D is angle 4. So when you write in a sequence, angle 1 plus angle 2 plus angle 3, 1, 2, 3 plus angle 4, 4, angle 5 plus angle 6, this, which is equal to 360 degrees, because here we have this. Any quadrilateral, connect the opposite vertices, make a diagonal. There will be always 2 triangles. Name them 1, 2, 3, 4, 5, 6 respectively in 2 triangles. In triangles, when you add these angles, 180, other triangle, again 180, add all these 6 angles, 1, 2, 6, you get 360. And when you have to prove A, B, C, D, the sum is 360, write like this A, B, C, D and group the angles like this. Finally, you get this, and already you have this. Hence proved. If you like the video, please like and subscribe. See you in the next class. Bye-bye.